Don't forget to subscribe and ring that bell.
Hey, welcome back. This is the second video for the June 2023 Algebra 2 exam. We are going to cover multiple choice problems 9 through 16. The first video, we did problems 1 through 8. And because this is the Algebra 2 Regents examination, we always get to use a calculator. Let's go. Just a quick reminder, you don't get partial credit. It's multiple choice. It's all or nothing. There are 24 questions. We are going to go over that middle third, 9 through 16. Let's begin. Number 9, which function has the characteristic as x goes to negative infinity, f of x, or y, okay, this is the same thing as y, goes to negative infinity. Well, on our axis, let's first look at this first thing here as x goes to negative infinity. On my x-axis, the positives are to the right. Okay, so if I go to the right forever, that's positive infinity. If I go to the left forever, where the negatives are, that's negative infinity. So when they say as x goes to negative infinity, they're really saying as the graph goes to the left, okay, is it going up or down? Meaning, my y's, the positives are up. So if I go up forever, that's toward positive infinity. But as I go down, that's negative. Going down forever would be negative infinity. So they're saying as x goes to the left, y would go down. Okay, so this just means down. So which graph out of the options they give us goes to the left and down? All right, let's start with option 1. I'm going to start on the right. I'm going to go left here. Okay, it's going down, but oh, as I go left, it goes up forever. See this? It can't be 1. Same thing for option 2. They give us another graph. I'm going to go from the right to the left because that's what they're telling me. As I go to the left here, I am going up forever and to the left, so it can't be 2. I am going to plug 3 and 4 in the calculator. Why would I sit here and try and figure this out in my brain when I have a calculator to do such things for me? So let's turn this bad boy on. I'm going to go to y equals, and I'm going to clear this out. And the first one I'm putting in the calculator is choice 3. It is 5 times 4 in parentheses, and I'm going to raise that to the negative x. If I graph that, okay, come on, man. Come on, man. Down and to the left. Well, no. If I look at choice 3 here, as I go from the right side to the left side, I'm going to the left, but I go up forever. Okay, so this graph, as it goes to negative infinity, yep, that's an 8, kids. Okay, as it goes this way, it doesn't go down, it goes up to positive. It's not 3. By default, it's 4. But what I want to do here is I actually want to put number 4 in the calculator for the sake of you understanding how to put log base in the calculator. Now, I can put log in the calculator. Okay, if I hit log here, but you see between the letter G and the parenthesis, I can't put the number here. And on the paper, there should be a 5 there. So if I want to change the base to log, I don't just press the log button. If I hit alpha window, and I'm sure this is on its choice 5, it says log base. This might be under the math menu. So I'm going to quit this here. Go to y equals. If I hit the math button, which is below the green button, alpha, okay, and I go to NUM, number, I'm sure if I go down, is it here? I don't really use this one that often. Why did that happen? No, would it be under math? Log base, there it is. If I hit the math button, it's choice A. Okay, so there it is, log base 5. Oh, but it needs to be negative log. So I got to come out front here and insert a negative sign. So it's negative log base 5 of negative x. Okay, if I graph this, as I go to the left, I should go down forever. And This graph, it gets so close to the y you really can't see it, but it does slowly go down forever, and it's going to the left and continually going down and down and down forever. Slowly, but it does. So it is choice 4. This is another one of those outlier problems that we really don't drill in class too often, but it has to do with factoring. What do I mean? I see x squared plus 3 squared minus 2 times x squared plus 3 minus 24. Now, if I wanted to, I could FOIL this, then I could distribute this 2 into here. I can get combined like terms and try and factor that. But to me, that seems like a lot. Okay, so what we're going to do is, you see this x squared plus 3? If I were to replace that with something, let's replace it, I don't know, with an m. If this was m squared, okay, minus 2 times m, okay, minus 24. Now, this becomes a lot easier to factor, okay? Two numbers. First of all, I have 3 terms. So I know I'm going to use my multiplies to the last number, okay? Multiplies to the last number and add to the middle number, okay? But is this a 1 in front of the m squared? It is. If it was not a 1, I would have to use slip and slide. But it is a 1, so I can go right to multiply and add, okay? 2 numbers that multiply to be negative 24 that add to negative 2. Negative 6 and positive 4. Okay, and I still have my m's, right? So I'm putting an m here and an m here. But they didn't give us m's. Visca, this is nice, because when I put a variable there, it becomes easy. What did we substitute the m in for? Wasn't m the same thing as x squared plus 3? I literally said, I'm going to make my m x squared plus 3, and I'm going to put my m in for both. Anytime I see an x squared plus 3, I'm going to put in an m. Well, guess what? We factor as much as we can. I'm going to put my x squared plus 3 back in for the m. That's going back in for my m, minus 6. Okay, and I got to do it here as well. X squared plus 3, and we have our plus 4. Now I just combine, like terms. I have x squared, 3 minus 6 is negative 3. All right? And I got my x squared, and 3 plus 4 is a positive 7. So that's my answer right there. X squared minus 3 and x squared plus 7 here. So basically, instead of giving us one variable, okay, like we made it here, to factor using multiply and add, they gave us this, okay, this x squared plus 3, this binomial. So the x squared plus 3, okay, if you will, I'm still going to find 2 numbers that multiply to 24 and add to negative 2, my negative 6 and positive 4, except the x squared plus 3 is going to go in front of each one. That's really all they're saying and doing. And we really don't do that. It's an odd, it's an outlier. Dirty that they did us like that on the test. But if you really understand factoring, you got it. My God, I wish every problem was like this. We are going to completely use the calculator for this. All right? What is the solution for the system of equations below? And they give us x plus y plus z is 2. X minus 2y minus z is negative 4. And x minus 9 plus z is negative 18. And we're not even missing a variable. Every equation has an x, a y, and a z. The first thing you should do is you should write the coefficient in front of each term. This is a 1, 1, 1, 1, 1, 1, 1. And what I'm going to do is I'm going to use a matrix, meaning I'm going to write these things with just the numbers without the letters, including what it equals. So my first line is going to be 1, positive 1, positive 1, positive 1, and 2. So I'm going to write 1, 1, 1, and it equals 2. Okay, if you need to. This is like my x column, my y column, my z column, and what it's equal to. Right? The next equation is going to be a positive 1, a negative 2, negative 1, and negative 4. All right? So it's 1, negative 2, negative 1, negative 4. And last but not least, positive 1, negative 9, positive 1, negative 18. Don't forget the negative signs, okay? So it's positive 1, negative 9, positive 1, negative 18. I'm going to put this without the x, y, and z here. Oh, boy. Into the calculator. Okay, into the calculator. Into my matrix. There we go. Man, I don't know what the heck is up with that. Oh, see what I did there. There we go. Man, everything is so weird. These boards are so sensitive, so touchy. Touchy-feely. All right, here we go. Boom. Boom. I need to enter this into my calculator, into the matrix. You see above the x to the negative 1 here. See this right here? In blue, it says matrix. Okay, I'm going to hit second and that button to get the matrix. Now, I'm going to edit one of my matrices. Okay, you see they give us all these matrices. I'm just going to use the first one, A. It's easier. And I'm going to select, it's already on choice 1, and hit enter. Now, I've got to make this. Notice that it's 3 tall and it's 4 across. I got 3 numbers going up to down and 4 numbers going left to right. So I want to make this 3, enter. See how I put 3 zeros there? Now that second one, I'm going to change to a 4 and hit enter. And I'm just going to enter the numbers that I have written down. So it's 1, 1, 1, 2. Okay. The next one, the purple ink, so to speak, is 1, negative 2, negative 1, negative 4. And the last one, oh boy, that's a negative 1. Always make sure you're not making any mistakes here. The last one is 1, negative 9, positive 1, and negative 18. I hit enter. So there are all the numbers. They are in just as I have this written on the paper. I need to quit. So I'm going to hit second, quit. I got to get out of here. Now I got to go back to the matrix menu. Okay, why do I got to go back? Because I want the calculator to do some math for me. So I'm going to move over to math. And you need to pick, okay, you need to pick the one that says RREF. Not ref, but RREF. That is basically the math command that says solve a matrix. All right. Well, remember how we had like A, B, C, D? We had so many matrices. We now need to tell the calculator which matrix to solve. I got to go back to the matrix menu one more time. These are the names of all the matrices. The one I use is the one I changed to 3. It's A. So I'm just going to hit enter. It's already selected. Solve my matrix, matrix A. Boom. These are my answers right here. Okay, so what I'm going to do here is show you how to read this thing. You should know already. Remember, let's see if we could do this. Make this a little bit bigger. Bring this down here. Here we go. These are my x's. My 1x should equal, this is what it equals, 0. So x is going to equal 0. These are my y's. My 1y is going to equal 2. And then my 1z will also equal 0. They have them written alphabetically. So it's going to be x, y, z. It's 0, 2, 0. And that's choice 3. That's just straight knowledge on how to use a calculator. Number 12, the roots of the equation x squared minus 4x minus 13 are. Well, first of all, you show roots are the same thing as zeros, x-intercepts, or solutions. So I'm asked to solve this. The first thing I'm going to do is set it equal to 0. I'm going to add 13 to both sides. So I have x squared minus 4x plus 13 equals 0. 3 terms, it is a 1x squared. So I could say to myself, 2 numbers that multiply to be 13 that add to negative 4. Guess what? There are none. Take a look at the 4 answers they supplied to me, okay? They do not look like nice whole numbers. I am going to have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this should be on the reference sheet provided, all right? And what is my a, my b, and my c? My a is 1. My b is negative 4. And my c is 13. All right, so we got negative b, which is negative 4, plus or minus the square root of b, which is negative 4 squared, minus 4 times a, which is 1, times c, which is 13, all over 2 times a, which is 1. Okay, notice that I put parentheses. If there's a b here, I put parentheses and the number in it. There's a b here, same parentheses and number. Okay, there's an a here and here. Guess what? There's where my parentheses and 1 went. And of course, my c, all by itself, that'd be nice if that went blue like I tapped it, is 13 right there. All right, let's put what we can in the calculator. It's not a decimal, so I can't just put it all in the calculator. So we're going to do a little bit of math, all right? When I negate a negative, that will turn to a positive 4. Now, I'm not going to use a square root symbol, but I'm going to put everything that's underneath the square root into the calculator. Mr. Visca can do this in my mind, but you guys will probably want to do this in the calculator, just to be safe. And you know what? It's always good for Mr. Visca to check it out as well. Just make sure he doesn't make a boo-boo. So I'm going to take in my parentheses my negative 4, square that, minus 4 times my a times my c. All right? Notice this is everything that's underneath the radical. I do not have the radical sign here. I hit enter. It's negative 36. Negative 36. So all of this underneath the radical is equal to negative 36 over 2. Well, this is great because I know the square root of 36 is 6. But what do I do with that negative? Remember, the negative pops out and becomes an I. So that's like saying I times the square root of 36. The square root of 36 is 6. So it's like saying 6I. All right, and it's still all over 2. Now, I don't see that as an answer because the 2, the 4, and the 6 all have a common factor. 2 goes into both 4 and 6. 2 goes into itself once. 2 goes into 4 twice. And 2 goes into 6 3 times. So that's like saying 2 plus or minus 3i over 1. And of course, anything over 1 is itself. Ooh, that was tricky. Not only did you have to do the quadratic formula, not only did you get a negative underneath the radical, so you had to do I, then it reduced afterward. Quadratic formula, imaginary numbers, and reducing fractions, all in one problem. Which expression is equivalent to 2x cubed plus 2x minus 7 all over 2x plus 4? Quick calculator cheat here. I only have one variable, my x, correct? Bang, 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 bang. Okay? And in all my answers, I only have an x. If they are asking which is equivalent, and this is the key word, I can put this into y1, and then I would have to graph each one of these as well. Whatever graph would be the same means it's equivalent. It makes sense. If the equation is the same, that's what equivalent means. It's equal. Equal is a math term that means same. Okay? If the equation is the same, the graph should be the same. So you can go ahead and do that and be like, I don't want to do any algebra. It's fine, But a good majority of this test, you might not do so good on. But you can do it that way. Even if you knew how to do this algebraically and you just wanted to save time, put it in a calculator and see which graph is the same as what they give us. All right? Now, I am going to show you how to do polynomial division. We're going to use reverse tabular. What does that mean? That means I am taking 2x plus 4, and I am dividing that into the numerator, right? But I notice that I don't have a term that has x squared in the numerator. I have 0x squareds in the numerator, don't I? Yeah, I don't have any. I have to write every term there, and if it's not there, I need to write it with a 0. So I need to have 2x cubed plus 0x squareds plus 2x minus 7, okay? And that's what I'm going to wrap around the outside here. So my 2x cubed goes out of this first corner, 2x cubed. This next corner is my 0x squareds. So how many more terms do I have? I have 2 more terms. So guess what that means? I need to draw 2 more corners. 1, there's a corner. 2, there's a corner. So now I have 2 more corners. Okay, and the next term is going to be 2x. And the last term is that minus 7. So now we're just going to get going with the dividing. This box has to be 2x cubed. So what do I multiply by 2x to get 2x cubed? X squared. And now I multiply x squared times my 4, and that goes here. It's 4x squared. What do I combine with 4x squared so that it ends up being 0? A negative 4x squared. And we're back doing the same thing again. What do I multiply by 2x to get negative 4x squared? Well, negative 2x times a negative 2x gives me negative 4x squared. And negative 2x times 4 is negative 8x. All right. Woo! What do I combine with a negative 8x to get positive 2x? Well, 10x minus 8x is 2x. Last but not least, what do I multiply by 2x to get 10x? 5, a positive 5. 5 times 4 is 20. Now, these are not the same, and this is how we have a remainder. How do I get from 20 to 7? Negative 7. Ooh, I got to subtract 27. And that adjustment is my remainder. Okay? So as I look up at my answers, okay, my answer to my division problem is x squared minus 2x plus 5 with a remainder of negative 27. My remainder always goes over what I'm dividing in. You see I got 2x plus 4? This remainder should be over 2x plus 4. And there is one answer on this paper or on this board that is that same thing, and that is choice 1. Oh, a lot of you right now are thinking, yeah, I would have probably graphed them, and that's fine. But at some point, you're going to need to know how to divide some polynomials. 14, a popular celebrity tracks the number of people in thousands who have followed her on social media since January 1st, 2015. A summary of the data she recorded is shown in the table below. You'll see the top, which is my x. Remember in problems 1 through 8, we mentioned the top is always the x, the bottom is always the y. Okay. And they give us the number of months as our x, and the y, or the output, is the number of social media follows in thousands. So just because it says 3.1, that's 3.1 thousands. That's 3,100, 7,500, 29,700, 49,700, and so forth. Okay? So we really just multiply that number by 1,000. Remember that. That will give us the exact number. Now, the celebrity uses an exponential regression. Ding, ding, ding. This is the magic word. Okay? To model the data. According to the model, about how many followers did she have on June 1st, 2018? There are 3 tasks to do in this problem. 1, I need to obviously find the number of followers. Okay, but how do I do that? 2, I need a regression. And 3, I need to figure out what X value is going to be June 2018, because that's what I'm going to want to put in my regression. That seemed like a lot. So let's just start with the obvious. We cannot solve this without getting that regression. Calculator time. All right, so I have this printed out in front of me, so I don't have to go back and forth between the board and the calculator. So I am going to clear this out and go to Stat, which is right here in the calculator. Boom. And Edit, which is choice 1. My X's, or my number of months, are going to go in the L1 column. So we have 2, 11, 16, 20, 27, 35, 47, 50, and 52. Now my number of social media followers, or the Y, that goes into L2. It's 3.1, 7.5, 29.7, 49.7, 200.3, wow, that's a big jump, 680.3, 5200.3, 8109.3, and 12,107.1. A lot of point threes. Notice that even though it doesn't show the 0.1 here, when I highlight it, okay, in black, it shows it down here. So it is there, just it can only show, what, 5 numbers at a time. That's good. Now I go back to Stat, and I want it to calculate an exponential regression, which means I got to go down to when I see exponential regression, right there, choice 0. I hit Enter, and I go to Calculate and hit Enter. This is only part of what I need, okay? This is only part of what I need. So let's go, and we'll go, I don't know, 3 decimal places out. So we've got Y equals my A value, which is 1.76. That will round up to an 8 because a number after it is 5 or bigger, times my B value, which is 1.185. This 4 will round up to a 5 because a number after it is 5 or bigger. Okay, raised to the power of X. All I did was take my A value and put it in for A, and I took my B value and put it in for B. Okay. And you would think, oh, hey, great, that's a lot that I did for this problem. But we ain't done. Now, I need to figure out how many followers. The followers are the Y. So I got to figure out this. But I need an X value to plug in. June 2018. X is the number since January 2015. Notice, I went up 3 years. I went from 2015 to 2018. 3 years, that's 36 months. That brings me to January of 2018. We still need to get to June of 2018. So June is 5 months after. So I need to add another 5 months. That's 41 months to get to June of 2018. It's a dirty multiple choice question. So my X, they want to know when X is 41, what's my Y value going to be? Goodness gracious. And it gets dirtier. Just wait, kids. All right. Our equation was 1.768 times 1.185 raised to the 41. Now that's 18, okay, 1861.8, let's call it. 1861.8. I don't see that anywhere. This is thousands. This is per thousand. So I got to multiply that times 1,000. And that's going to give me 1861800. So about 1 point, the closest one, okay, because it says about, is this right here. How come it's so far off? Because we cut off so many decimals when we rounded, it will slightly affect our answer. That was a lot of work for a multiple choice problem. Problem 15. Luminescence is the emission of light that is not caused by heat. A luminescent substance decays according to the function below. I equals I sub 0 times E raised to the 3 times negative t over 0.6. This function can best be approximated by. This sounds so intimidating, but really, notice one thing. There's an I here, there's an I here, 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 here. That's the same. There's an I sub 0. Oh my goodness, I sub 0, I sub 0, I sub 0, I sub 0. So what they're really just testing you on is to see if you can make this part right here equal to this part right here. All right? So let's just do that. I've got E3 times negative t, in the calculator I want to use x, 0.6. If I multiply that together, I get negative 3t over 0.6. What I'm now going to do, because in the calculator, notice that there's one more thing similar about all these problems. T. So I don't even really need the t here. Okay, so what I'm going to do is I'm going to kind of break apart this. I'm going to take my e. I'm going to take e raised to the negative 3 over 0.6 and keep the t part of my exponent on the outside. So I'm just going to put this in the calculator. I'm just going to put this. Yep, I hit the green ink. Put that in the calculator. That's all I'm going to do. I'm going to see if it looks like one of these options they gave me. So they're really just testing you to see if you can break apart that exponent. Okay, e to the, okay, so I've got e. I'm going to hit the blue button second, and above ln here, it says e to the x. And that's a fraction of y equals, enter, negative 3 over 0.6. And that's 0.0067. 0067 raised to the t. Do I have that? Oh my goodness, I sure do. Choice 3. Again, changing your exponent, knowing how to multiply a fraction times a whole number. Okay? Whew! Last but certainly not least. Last but not least. The heights of the students at Central High School can be modeled by a normal distribution. Oh, I'm going to use a calculator. As soon as I see that, I love it. With a mean of 68.1 and a standard deviation of 3.4 inches. According to this model, approximately what percent of the students would have a height less than 60 inches or greater than 75 inches? Okay, I need to do two separate problems and add them together. Okay, I need to find the height where it is less than 60. If you want to write less than 60, go right ahead. And I want to find the height which is greater than 75. So this is bigger or greater than. Okay, they want to find all of those. So I got to find those separately and add them together. All right. Oh, I love using the calculator for this type of stuff. It is cake. Here we go. Notice normal distribution. In the calculator, above this button that says vars, it says distribution. It's shorthanded. D-I-S-T-R means distribution. And I want to pick normal CDF. I don't even know what PDF does, but normal CDF. It's telling me, okay, my bounds, lower bound and upper bound. So all the kids lower than 60. So I don't know. I'm going to pick a number that's abnormally low. 2 inches. No one is 2 inches tall. So if I go from 60 inches to 2 inches, I will cover everybody that's shorter than 60 inches. Okay? This little smushed M means mean. That is 68.1. And that little pigtail O thing means standard deviation. That was 3.4. I'm going to paste that into this little normal CDF thing, and that is 0.008. Okay, 0.008. 0.008, that's a probability. If they want a percent, I got to slide that over twice. So it's 0.8%. Now, I just do the same thing, but 75 and more. Okay, so let's do that one more time. I'm going to go second distribution. I'm going to pick normal CDF. This time, I'm starting at 75, and I want everybody taller. Like, no one is 1,000 inches tall. So if I put 1,000 inches here, that will cover everybody that's 75 and bigger. Okay, the mean is still the same, and the standard deviation is the same because it's the same scenario. Okay, and I'm going to paste this, and I'm going to get 0.0212. 0.0212. That's a probability. In order to make it a percent, I just slide that decimal over twice. It's 2.12%. I got to add these. Okay, 2.12 plus 0.8 is 2.92%. 2.92%. 92. 2.92. Yeah, it's 9.8. Wow. So why was that or greater than? Oh, less than 60 inches. I should have went, okay. It doesn't include 60. Less than 60. On my paper, I should have written 59. I don't want 60. I just want less than 60, not less than or equal to. And I don't want 75. I just want the people bigger than 75. So it should go 76. It should be 76 or higher. Because in my calculator, it includes the number. So that's the explanation for that little thing that's off. Okay? And I should get 2.98. Perfect. All right? Wow, that's a tough exam. I'll see you for video 3.
Don't forget to subscribe and ring that bell.